Let's talk about one of the most controversial features in Python, the GIL or Global Interpreter Lock. In essence, this feature disallows parallel processing and restricts your program such that it can only run one thread at a time. To better understand this, let's have a look at how traditional programs are executed by your CPU. In 2023, a typical CPU has 4 cores and between 4 to 8 threads. To keep our example simple, we'll imagine that each core only has one hardware thread. Each CPU core is a physical processing unit that is capable of handling one task at a time. The more cores we have, the more tasks we can process at the same exact time. The types of tasks that CPU cores handle are called software threads. It can get confusing, but software threads are created by applications, while hardware threads exist on the physical CPU. From now on, we'll only be referring to software threads. Now, software threads are portions of applications or programs that can be run independently by a CPU core. The more cores we have, the more threads we can execute at the same time. This means that we can speed up our programs by splitting them into multiple threads. So let's take an example where we want to sum the numbers from 1 to 20. Well, if we do this with a single thread, we're only utilizing one of our 4 CPU cores. To speed up this operation, we can split our program into 4 threads, where each thread is responsible for summing a portion of the numbers. Thread 1 can sum the numbers 1 to 5, thread 2 sums 6 to 10, thread 3 sums 11 to 15, and thread 4 sums 16 to 20. Now that we're using 4 threads, we can use 4 CPU cores, and we've sped up our program by 4 times. Now, this adds a bit of complexity, but overall, it's worth the trade-off. Now, here comes the bad news. In Python, it doesn't quite work this way. Whenever we execute code, we use something called an interpreter. To keep it simple, this is what's capable of understanding the code and processing the instructions that we wrote. That means that in the previous example, each one of our threads will need to access a code interpreter whenever it's executing instructions. In most languages, this is fine. Multiple threads can use the same interpreter at the exact same time. But in Python, we have something called a lock. Now, a lock is essentially a gate that only lets one thread through at a time. Since we have a lock on our Python interpreter, that means that even though we have 4 threads, only one can use the interpreter at a time. If a thread is using the interpreter, it can release the lock, allowing another thread to access it. But only one thread can be using the interpreter at the same time. That, in essence, is the Python Global Interpreter Lock. Now, at this point, you might be asking yourself, why would I ever use multiple threads in Python? Well, the answer is when you're working with network or input-output type operations. Now, imagine a simple example where a user visits your app. The app may need to load the user's friends and chat history from a file or from some API. Now, while this loading is happening, you still want your user to be able to interact with the app. If you were to place all of this logic in one single thread, the app would freeze, waiting on the data to be loaded before the user can do anything else on the app or before you can load additional data. Now, if you split this operation into 3 threads, even though only one thread can execute at a time, you can execute a different thread while one thread is waiting on a result from the file system or the server or network. So what we'll do here is we'll make a thread to load the chat history, a thread to load the friends, and a thread that runs the user interface. We start by running the chat history thread, which quickly sends a request to a server for some results. This thread then hangs, waiting on a result. Now, as soon as it starts waiting, we can switch to execute a different thread, in this case, the friends thread. Same here, as soon as it starts waiting, we execute the user interface thread, allowing the app to run while the data is loading. Now, once we receive the data, we can quickly switch back to the other threads, process that data, and move on. This allows us to execute data concurrently, so the CPU can always be working and never waiting on a result that we don't have control over. Creating multiple threads allows us to switch between those different threads, so we're always utilizing the CPU. So now that we have a good understanding of threading, let's briefly discuss multiprocessing. Python has a multiprocessing module which allows us to create separate processes. Now, as a simplification, you can imagine that each process spawns its own instance of the Python interpreter. This means that we can sidestep the global interpreter lock and run a truly parallel application. Now, multiprocessing is not as easy to handle as multi-threading, but this is a solid solution to avoid the global interpreter lock. So now, at this point, you know about one of the most controversial features in Python, the global interpreter lock. If you want to learn more about Python, make sure to subscribe to this channel. I look forward to seeing you in another one.